Basic Electrical Engineering MCQs. Multiple choice questions. List of Basic Electrical Engineering MCQs. 1. Amongst which of the following is the correct about the flow of current in gases and liquids? A. The flow of negative ion and positive ion is in the same direction. B. The flow of positive ions is in one direction and the flow of negative ions is in the opposite direction. C. Only positive ion flow in one direction. D. None of the above. Answer: B. The flow of positive ions is in one direction and the flow of negative ions is in the opposite direction. Explanation: due to ion mobility, electrical conduction occurs in gases and liquids. Positive ions flow one way and negative ions flow the other. In gases and liquids, the electric current is formed by this specific ion movement. 2. Conventional current describes. A. Conventional current describes the direction of positive charge flow. B. Conventional current describes the direction of negative charge flow. C. Conventional current describes the direction of positive and negative charge flow. D. None of the above. Answer: A. Conventional current describes the direction of positive charge flow. Explanation: in terms of electric circuits, the conventional current model is a type of theoretical model that describes the direction of positive charge flow. 3. In how many ways does electric current travel in a semiconductor? A. 5. B. 4. C. 3. D. 2. Answer: D. 2. Explanation: the behavior of current in semiconductors is determined by the type of semiconductor material used as well as the conditions outside such as voltage applied etc., but generally in two ways electric current flows in semiconductors. Electron current. Hole current. 4. Amongst which of the following is true about resistance? A. The level of resistance is always constant. B. Resistance only exists in conductors. C. Individual resistances connected in series have the same effect as a single huge combined resistance. D. All of the above. Answer: C. Individual resistances connected in series have the same effect as a single huge combined resistance. Explanation: individual resistances connected in series have the same effect as a single huge combined resistance. This is because each resistor has the same current flowing through it, and the voltage across the combination equals the total of the voltages across each resistor. 5. The decrease in electrical potential, voltage, between two places in an electrical circuit or component is referred to as A. Electric current drip. B. A voltage drop. C. Resistance sinking. D. Current dribbling. Answer: B. Voltage drop. Explanation: the decrease in electrical potential, voltage, between two places in an electrical circuit or component is referred to as voltage drop. The magnitude of the voltage drop is influenced by the amount of current traveling through the component as well as the component's resistance. 6. Why copper and aluminum are used as conductors? Choose the correct answer. A. Because they offer no opposition to the flow of current. B. Because they offer high opposition to the flow of current. C. Because they offer very little opposition to the flow of current. D. Because they have very little dribbling power. Answer: C. Because they offer very little opposition to the flow of current. Explanation: copper and aluminum are commonly used as conductors because they offer less resistance to current flow. This is because of their low electrical resistance, which allows electric current to flow through them with little energy loss in the form of heat. 7. Amongst which of the following is the other name for voltage drop? A. Voltage dribbling. B. Current drop. C. Electric current set down. D. Line drop. Answer: D. Line drop. Explanation: line drop is the other name for voltage drop. The magnitude of the line drop is determined by parameters such as the amount of current flowing through the conductor, the length of the conductor, and the material used to make the conductor. 8. Amongst which of the following is the unit of line drop? A. Volts. B. Watts. C. Ohms. D. Decibels. Answer: A. Volts. Explanation: volts is the unit of line drop. In mathematical terms, 1 volt equals 1 joule/1 coulomb. A volt is a unit of measurement for the amount of electrical energy delivered to each unit of electric charge traveling through a circuit. 9. Capacitors are which type of electronic component? A. Active electronic component. B. Passive electronic component. Answer: B. Passive electronic component. Explanation: passive components do not require an external power source to operate. They store, filter, or distribute energy without actively generating or managing it, and capacitors fall under this category of electronic component. 10. Among which of the following is commonly referred to as the insulating layer between capacitor plates? A. Conductive plate. B. Open plate. C. Dielectric. D. Electrolyte. Answer: C. Dielectric. Explanation: the dielectric material is sandwiched between the conductive plates of a capacitor. It functions as an electrical insulator, preventing direct electrical contact between the plates and blocks DC current. 11. Amongst which of the following is true about the voltage in parallel components? A. Each parallel component has a different voltage. B. Each parallel component has the same voltage. C. Each parallel component has a different voltage, depending upon the conditions. D. Both A and C. Answer: B. Each parallel component has the same voltage. Explanation: all components, resistors, capacitors, inductors, etc., in a parallel circuit are connected across 2 points, so their voltages are the same. 12. Each individual resistance is smaller than the total resistance. This statement is applied to which of the following type of circuit arrangements? A. Parallel circuit arrangement. B. Series circuit arrangement. C. For both A and B. D. None of the above. Answer: A. Parallel circuit arrangement. Explanation: each individual resistance is smaller than the total resistance, applies specifically to parallel circuit designs because current flows along several channels in a parallel layout, lowering the effective resistance of the entire circuit. 13. Amongst which of the following states is the correct relationship between the conductance and the resistance in a parallel circuit combination? A. Conductance is directly proportional to the square of resistance. B. Conductance is inversely proportional to the square of resistance. C. Conductance is directly proportional to the resistance. D. Conductance is inversely proportional to the resistance. Answer: D. Conductance is inversely proportional to the resistance. Explanation: the relationship between conductance, G, and resistance, R, in a parallel circuit combination is that conductance is inversely proportional to resistance. This can be stated mathematically as G equals 1/R. As more resistors are connected in parallel, the overall conductance rises while the total resistance falls. 14. Amongst which of the following states is the correct relationship between the conductance and the resistance in a series circuit combination? A. In a series circuit, total conductance is equal to the reciprocal of the sum of its resistances. B. In a series circuit, total conductance is equal to the reciprocal of the product of its resistances. C. In a series circuit, total conductance is equal to the reciprocal of its resistances. D. None of the above. Answer: A. In a series circuit, total conductance is equal to the reciprocal of the sum of its resistances. Explanation: in a series circuit, total conductance is equal to the reciprocal of the sum of its resistances. Mathematically, we can write this as total conductance, G total, equals 1/1/R 1 plus 1/R 2 plus 1/R 3 plus. plus 1/Rn. 15. Why do battery cells in flashlights use a series connection? A. To provide higher resistance. B. To provide higher conductance. C. To provide a higher voltage. D. All of the above. Answer: C. To provide a higher voltage. Explanation: when battery cells are connected in series, their voltages add together, resulting in a larger total voltage across the entire battery pack. Therefore, battery cells in flashlights provide higher voltage in series connection. 16. Amongst which of the following is the correct term for the points in a network where three or more circuit elements come together? A. Branch. B. Mesh. C. Node. D. Junction. Answer: D. Junction. Explanation: junctions are points in a network where three or more circuit elements come together, also referred to as a connection point. Junctions are important in circuit analysis because they identify nodes in the circuit where KCL can be used to calculate unknown currents and voltages. 17. Amongst which of the following principle is applied at nodes? A. KCL. B. KVL. C. Both. D. None. Answer: A. KCL. Explanation: nodes in a circuit are sites where two or more circuit elements are joined. KCL is utilized at nodes to detect unknown currents and to understand how currents split or combine at these connection points while evaluating circuits. 18. Amongst which of the following principle is dependent on the concept of the loop? A. KCL. B. KVL. C. Both. D. None. Answer: B. KVL. Explanation: KVL principle is dependent on the concept of a loop. A loop is any closed channel within the circuit that does not pass through the same node more than once. 19. Loop is the subset of mesh. True or false? A. True. B. False. Answer: B. False. Explanation: false, a loop is not a mesh subset. A mesh, on the other hand, is a subset of a loop. It is because the mesh is a special form of a loop that is independent and does not enclose any other loops within it. 20. Electricity delivered to or consumed by an electronic device at any given moment is called A. Fixed power. B. Rapid power. C. Shifted power. D. Instantaneous power. Answer: D. Instantaneous power. Explanation: electricity delivered to or consumed by an electronic device at any given moment is called instantaneous power. The main utilization of this concept is in understanding the behavior and efficiency of alternating current circuits. 21. When the work is done at a constant rate, the average and instantaneous power become A. 0. B. Negative. C. 1. D. Equal to each other. Answer: D. Equal to each other. Explanation: work done at a constant rate results in equal average power and instantaneous power. 22. Amongst which of the following type of energy that an object contains as a result of its motion? A. Potential energy. B. Mechanical energy. C. Kinetic energy. D. Electrical energy. Answer: C. Kinetic energy. Explanation: kinetic energy is the type of energy that an object has as a result of its motion. It is proportional to mass and velocity. Kinetic energy increases as an object moves faster or has a greater mass. 23. Amongst which of the following type of energy is heat? A. Potential energy. B. Mechanical energy. C. Kinetic energy. D. Electrical energy. Answer: C. Kinetic energy. Explanation: heat is a type of kinetic energy that is transmitted from one item or system to another due to temperature differences. 24. Amongst which of the following is true about potential energy? A. Potential energy depends upon velocity. B. Potential energy is calculated as the product of mass, m, gravity acceleration, g, and height, h. C. Potential energy is calculated as the sum of mass, m, gravity acceleration, g, and height, h. D. Potential energy is a scalar quantity. Answer: B. Potential energy is calculated as the product of mass, m, gravity acceleration, g, and height, h. Explanation: potential energy is calculated as the product of mass, m, gravity acceleration, g, and height, h. Potential energy, Pe, equals m asterisk g asterisk h. Potential energy is a vector-like quantity that is independent of velocity. 25. Amongst which of the following types of energy is solar energy? A. Nuclear energy. B. Chemical energy. C. Radiation energy. D. Both A and C. Answer: C. Radiation energy. Explanation: solar energy is a type of energy that is largely classified as radiation energy, also known as electromagnetic radiation. This radiation energy is often known as solar radiation. 26. Amongst which of the following is the unit for electrical resistance? A. Joule. B. Coulomb. C. Ohms. D. Watt. Answer: C. Ohms. Explanation: the ohm symbol is the unit of electrical resistance. An ohm is a unit of measurement for the amount of resistance an electrical conductor provides to the flow of electricity. 27. Amongst which of the following states the correct relationship between the conductor resistance and its length? A. The conductor's resistance is directly proportional to its length. B. The conductor's resistance is directly proportional to the square of its length. C. The conductor's resistance is inversely proportional to its length. D. None of the above. Answer: A. The conductor's resistance is directly proportional to its length. Explanation: the resistance of a conductor grows proportionally to its length. This relationship is one of the factors influencing a conductor's resistance. 28. The conductor's resistance is directly proportional to its area. True or false? A. True. B. False. Answer: B. False. Explanation: the resistance of a conductor is not directly proportional to its area. Instead, a conductor's resistance is inversely proportional to its cross-sectional area. 29. Materials that have high electrical resistivity are commonly referred to as A. Dielectrics. B. Conductors. C. Insulators. D. Both A and C. Answer: D. Both A and C. Explanation: both dielectrics and insulators have high electrical resistivity because they hinder the passage of electric charges and do not readily conduct electricity. 30. Amongst which of the following concept is dependent on temperature? A. Resistivity. B. Capacitance. C. Electric flux. D. Relative permittivity. Answer: A. Resistivity. Explanation: the resistivity of an element varies with temperature, and for most materials, resistivity increases as temperature rises. This is referred to as a positive temperature coefficient of resistance. 31. Copper and aluminium have resistivity. A. High level. B. Low level. Answer: B. Low level. Explanation: copper and aluminium have low-level resistivity, therefore, they are ideally used for making wires. 32. Amongst which of the following has low resistivity? A. Arsenic. B. Silicon. C. Gold. D. All of the above. Answer: C. Gold. Explanation: gold is known for its low resistivity, but because it is expensive it is not utilized to make wires. 33. amongst which of the following statement is true, if a material has a positive temperature coefficient of resistance? A. The material's resistance decreases as temperature increases. B. The material's resistance increases as temperature increases. C. The material's resistance increases as temperature decreases. D. None of the above. Answer: B. The material's resistance increases as temperature increases. Explanation: a material with a positive temperature coefficient of resistance, TCR, has a resistance that increases as the temperature rises. Most conductors, including metals such as copper, aluminum, and silver, exhibit this characteristic. 34. Amongst which of the following is the unit of temperature coefficient of resistance? A. Ohms per meter. B. Ohms per volt. C. Ohms per watt. D. Ohms per degree Celsius. Answer: D. Ohms per degree Celsius. Explanation: ohms per degree Celsius. The temperature coefficient of resistance, TCR, is measured in ohms per degree Celsius, omega/degree C. It calculates the change in resistance of a material per degree Celsius change in temperature. 35. The temperature coefficient of the semiconductor material is A. Negative. B. Positive. C. 0. D. Infinity. Answer: A. Negative. Explanation: semiconductor materials often have a negative temperature coefficient. This indicates that as the temperature rises, the electrical resistance of semiconductors reduces. 36. In circuit analysis, how many different types of reference nodes are used? A. 5. B. 4. C. 3. D. 2. Answer: D. 2. Explanation: a reference node in electrical circuit analysis is a specified node used as a reference point for measuring voltages and currents in a circuit. Chassis ground and earth ground are the two sorts of reference nodes. 37. When a voltage source, such as a battery, connects two nodes directly together in an electrical circuit, it is called a fixed node. B. Super mesh. C. Mesh voltage. D. Supernode. Answer: D. Supernode. Explanation: when a voltage source, such as a battery, connects two nodes directly together in an electrical circuit, it is called a supernode. The primary goal of establishing a supernode is to simplify the nodal analysis procedure. 38. Do supernodes have their voltage? A. Yes. B. No. Answer: B. No. Explanation: a supernode has no independent voltage. They are especially useful for evaluating circuits with dependent sources or complicated circuit topologies. 39. Can we use mesh analysis for nonplanar circuits? A. Yes. B. No. Answer: B. No. Explanation: no, we cannot use mesh analysis for nonplanar circuits, it can only be used for planar circuits. A planar circuit is an electrical circuit in which all of the components, connections, and elements are located in a single plane or flat surface. 40. Amongst which of the following is an example of nonlinear devices? A. Transistors. B. Capacitors. C. Resistors. D. Inductors. Answer: A. Transistors. Explanation: a transistor is a nonlinear device because its output current or voltage is not directly proportional to its input current or voltage. 41. According to the superposition theorem, all components must be A. Unilateral. B. Lateral. C. Bilateral. D. None of the above. Answer: C. Bilateral. Explanation: according to the superposition theorem, all components must be bilateral. A bilateral component has the same behavior when current flows through it in both directions. 42. amongst which of the following statement is true about the superposition theorem? A. The superposition theorem can be only applied to DC circuits only. B. The superposition theorem can be only applied to AC circuits only. C. The superposition theorem can be applied to DC and AC circuits both. D. None of the above. Answer: C. The superposition theorem can be applied to DC and AC circuits both. Explanation: the superposition theorem applies to both direct current, DC, and alternating current, AC, circuits. The theorem is a generic notion that applies to linear circuits regardless of the type of source, DC or AC, used. 43. Norton's theorem is used to convert a current source to a voltage source. True or false? A. True. B. False. Answer: B. False. Explanation: false. Norton's theorem does not transform a current source to a voltage source. It is an equivalent representation of a linear circuit with many sources and resistors. 44. Is Norton's theorem valid for both linear and nonlinear circuits? A. Yes. B. No. Answer: B. No. Explanation: Norton's theorem does not apply to nonlinear circuits. Norton's theorem, like Thevenin's theorem, is limited to linear circuits. 45. Electric flux lines are always closed loop. True or false? A. False. B. True. Answer: A. False. Explanation: the electric flux lines are straight and parallel to each other in a uniform electric field between two parallel charged plates. They are not closed loops because they stretch from one plate to the other without forming a closed path. 46. Amongst which of the following states is the correct relationship between the electric flux density and electric field intensity? A. Electric flux density, D, is directly proportional to the square of the electric field intensity, E. B. Electric flux density, D, is inversely proportional to the electric field intensity, E. C. Electric flux density, D, is directly proportional to the electric field intensity, E. D. Electric flux density, D, is directly proportional to the sum of the electric field intensity, E. Answer: C. Electric flux density, D, is directly proportional to the electric field intensity, E. Explanation: the electric flux density, D, is directly proportional to the electric field intensity, E, which indicates that as the electric field intensity increases, so will the electric flux density. 47. Amongst which of the following is the SI unit of electric flux density, D? A. M2B cm C/M2D Joule. Answer: C. C/M2. Explanation: the SI unit of electric flux density, D, is coulombs per square meter, C/M superscript 2. 48. Amongst which of the following concept is known for quantifying the material's capacity to hold electrical energy in an electric field? A. Polarization. B. Dielectric breakdown. C. Energy density. D. Permittivity. Answer: D. Permittivity. Explanation: the permittivity of a material is a measure of its capacity to store electrical energy in an electric field. 49. The relative permittivity of air is equal to A. 0. B. -1. C. 1. D. Infinity. Answer: C. 1. Explanation: the relative permittivity of air is equal to, in other words, air has the same permittivity as open space, vacuum. The relative permittivity of the vacuum is also 1. 50. Amongst which of the following factor does not play any role in the charging and discharging rate of a capacitor? A. Capacitance. B. Applied voltage. C. Resistance. D. Relative permittivity. Answer, D. Relative permittivity. Explanation: relative permittivity, also known as dielectric constant, is a property of the dielectric material used in the capacitor, and it has no direct influence on the charging and discharging rate of the capacitor.